What's up y'all, it's Mr. Canada. In this video, we're going to be talking about function notation and using that notation to evaluate functions. Let's go ahead and get started. So what is function notation to begin with? Basically, function notation is a way of differentiating between different equations, tables, and graphs. Basically, we're going to try to name the function so that we can be really specific about identifying one graph over the other, which is super useful because if someone were to tell you, hey, I want you to look at that graph over there, or hey, I'm talking about this equation, there could be countless graphs or countless equations on whatever you're working on. Function notation helps us add a name to each specific equation and table. Let's go ahead and see what it looks like. So function notation looks like this. So function notation basically starts off with this. It starts off with the name of the function, which this we pronounce as f of x. Now this could really be any combination of letters. So for example, you could also have g of x, and you could also have h of x. You can pretty much have a combination of whatever you want. I can keep going. I could also say t of y. I could also say p of t. I could go on. I could make countless names. So what's the point? The point is at the beginning of the part is telling you the name of the function. So, for example, if you had two different graphs, you can name one graph f of x, and you can name the second graph g of x. As long as you're being very specific, that's going to be one way that you can differentiate. There is a second part to function notation. So alongside with the name, there is also the equation part of the function. So for example, f of x equals, basically the equation would be located right here. I'm going to go ahead and abbreviate it, equation. Basically, it comes down to two things. Function notation helps us identify where the inputs are going and where the outputs are going to be also coming out. So for example, if you have something like this, basically whatever is on the inside, basically this x, this is going to be your input. This input is going to be going into the equation. You're going to be doing some math. It's going to be calculating like a calculator normally would. And what it comes out of, whatever numerical answer, whatever you get out of it, is going to be your output. This is really useful because we can use function notation to take an equation and turn it into a table, or take that equation and turn it into the graph. We're going to be talking about that a little bit more next time, but this is the main idea. Function notation is super useful in that it helps us evaluate equations or expressions. One more thing before we move on to a couple of examples. Another good thing that you should know is that function notation can be interchangeably, could be used at the same time as equation notation, just y. So you might have heard this before, that f of x is the same as y. Basically, it's trying to say that you can use each one interchangeably. So that means that if you don't like using, let's say, f of x equals, let's just say 2x as an example, you could also say that y is equal to 2x, and both of these would mean the exact same thing. It's basically a function. You are allowed to use each one interchangeably. Now, I did mention that function notation is super useful in helping us evaluate functions. You might have evaluated functions already before. You might have done evaluating expressions, where you take a number or numbers and you would just plug them into the right spot, and then just doing some multiplication or some addition, and you would get an answer. Basically, function evaluation is the exact same thing. It's just organized a little bit different. Let's go ahead and see. So function notation can be useful for the following. Let's say they give us a function f of x equals 2x plus 3. And they asked us to evaluate f of 5. So what should we think about? Basically, this is what you should be thinking about. Right now, notice that in place of where the x used to be, now there is a number 5. Basically, that's telling you that the input of the equation, the input into the variable x, is going to be a 5. So that means that wherever you see an x, or wherever you see a variable in your function, you're going to replace that with the number 5 or with whatever the input is. So in this case, I'm going to go ahead and do one really subtle thing, and trust me, this is going to be really helpful. Anytime you're going to evaluate something, I would recommend looking at your entire equation and putting placeholder parentheses, meaning take out the variable and put some parentheses there in place. Now, why should you do that? You should do that because then it's more helpful, more organized, so you know where you're going to be plugging in that 5 into, and then plus 3. Again, what we're going to do is that we're going to take this 5 that was in place of the x, and we're going to go ahead and plug it in. So wherever I used to see an x, I'm going to go ahead and plug in a 5. So in this case here, I'm going to go ahead and place 5. Now all we have to do is simplify, meaning we have to multiply and add stuff if necessary. So 2 times 5 is 10, and then 10 plus 3 is going to be 13. So 10 and then plus 3, that's going to be equal to 13. Pretty easy. So whenever they ask you to evaluate something, keep this in mind. Keep in mind what number is in place of the variable, what your input is. Take that input it for every variable you see in your equation, and then simplify. Let's look at another example. Let's use this second function here. G of x equals 4 times 1 minus x. Let's go ahead and evaluate f of negative 2. Now, it's super important, again, that anytime that you're going to plan on inputting something, that you put parentheses, placeholders, in place of where that variable used to be. So in this case, what I'm going to do is that I'm going to go ahead and put parentheses around where the x used to be. The x is right here, so I'm going to put parentheses there. It's an empty spot right now. What's my input? My input is always on the inside. So my input here is negative 2. So that means I'm going to go ahead and plug in a negative 2 into my equation. So all we have to do from here is simplify. So 1 minus negative 2, whenever you subtract a negative, it's a positive. So this is going to be 4, 1 plus 2. Order of operations, we do the stuff on the inside. 1 plus 2 is 3. And then we multiply. 4 times 3 is 12. Now, I forgot to mention one thing. What you can do after you have your input is say this. F of 5, in the previous example, is equal to 13. We say that when you input a 5, the output is going to be 13. So, another way that you can write this is say that when x equals 5, y is equal to 13. Both ways have their own respective uses. The first way is more of a function-oriented way of writing the answer, while the second way more or less tells you what the input is with respect to the output. I would say write both down so you can get a better idea about how to look at both visualizations. Same thing over here. So that means that after we're done, when we inputted negative 2, f of negative 2, our final result was 12. In other words, when x was equal to negative 2, y was equal to 12. So again, what's the idea here? We're going to take the number that's given to us, the number that they're asking us to evaluate, and we're going to input it into our variable and simplify. So we're almost done here. Let's look at one more example. H of x is equal to x squared plus 2x plus 1. So let's go ahead and evaluate this time h of 2. So what's the game plan here? Well, you might notice that we actually have more than one variable in our equation. We have more than one letter. So what's the game plan? The game plan is simple, and it's the same. Wherever you have an x or whatever variable you're working with, take that x out or take that letter out and put placeholder parentheses. In this case, we're going to have more than one placeholder in our equation. So here we're going to take out that x, we're going to put some parentheses there. Here we're going to take out the other x, put some parentheses there, and then we're just going to bring down that plus 1. Now from here, all you have to think about is this. What is my input? My input is right here. It's this 2. This is my input. So I'm going to take that 2 and input it in the spots where x used to be. And now we're going to simplify. So 2 to the power of 2 is going to be 4. 2 times 2 is also 4. And then we're bringing down that 1. So 4 plus 4 is 8, plus 1 is 9. So that means that when you evaluate h of 2, your final result is going to be 9. Or when x equals 2, y is going to be equal to 9. So what's the big idea? You're taking the input, you're plugging it in, and you're simplifying. Now, there are going to be situations where instead of evaluating a number, they're going to be asking you to evaluate an expression. Let's go ahead and see some examples of how to do that. So, let's go ahead and make some space up here, because I do want to make this very specific. So let's go ahead and make ourselves some space. We're going to go ahead and erase this for now. It'll be okay. You can just go earlier in the video if you need to write that down one more time. So how does evaluating a letter even look like? Well, let's look at an example. Let's say that with the first case, they're asking us to evaluate f of, let's just say, the letter A. So what's the idea? The idea is the same. Anytime that you are replacing the original variable with a number or a different letter, make your placeholder parentheses. So in this case, I'm going to go ahead and put placeholders around where my x used to be. And again, you have to ask yourself, well, what's my input? My input this time is the letter A. So I'm going to go ahead and put a letter A in here. Now, how do we simplify this? Well, this is just 2 times A, which is just 2A, and then we just do plus 3. But wait a minute, this isn't a numerical answer. It's not just one single number at the very end. That's okay. Basically, the idea is whenever you're going to plug in a variable, your final answer usually is going to be an expression. And that's going to be alright. So don't expect your answer to always be a numerical answer. Sometimes your answers can be expressions. Here's another example. Let's say that they asked you to evaluate f of, let's say, 2x plus 1. Oh, well, now you just made it more complicated. Why are we just plugging in whole equations in there? Here's the point. The point is that if you know how function notation works, if you know how inputs work, no matter how ugly the input looks, it's always going to be the same strategy every single time. So that means that this is 2. We're going to put our placeholder where x used to be, and then we're just going to bring down that 3. Again, that's the whole idea. Put your placeholders so it's easier to think about what your input is. In this case, your input is 2x plus 1. So in here, we're going to go ahead and put 2x plus 1. And now we're going to simplify. Here, to simplify this, we're going to use a distributive property, meaning that we're going to take the number on the outside and we're going to multiply it to the stuff on the inside. So 2 times 2x is 4x, 2 times 1 is 2, and we're going to just copy down that 3 one more time. And then finally, this is 2 plus 3 are like terms, so your final answer is going to be 4x plus, oh, it's not 3, it's plus 5. You probably already guessed that, smarty pantses. So, what's the idea with function notation even with variables? Same thing. I'm going to keep repeating this the whole time. The number or letter or expression on the inside is your input. That's what you're plugging in. And it doesn't matter how simple, how pretty, how ugly, or how long that input looks like. All you're doing is replacing the variable in your equation with that input and then simplifying if necessary. Well, I hope you guys learned something new today. If you have any questions, please leave them in the comments below. If you liked the video, give the video a like and subscribe to my channel for more Algebra 1 videos. And as always, please take care, and I'll see you guys next time.